Hello and welcome to this video about determinant proofs. In this video we'll prove this theorem, that if you add a multiple of one row to another, then this doesn't change the determinant. I'm using the same tactic of using the sum of permutations to calculate the determinants, so I guess that you might be getting used to it by now. So this is a picture of what these matrices look like. Matrix A represents the matrix before the row addition. Matrix B represents C times row Q added to row P. I've circled the place where it's been added in blue. So now to start the proof, we'll assign A and B to be these matrices. And this is what the entries in each of these matrices are. They are the lowercase letters corresponding to the names of these matrices. And this is how these entries are related to each other. They are exactly the same except for row P, where a multiple of row Q has been added to this row. So now we'll expand out the determinant of matrix B using the definition, and we'll have to eventually get it to equal the determinant of matrix A. And we'll expand it out to see rows P and Q in particular. We can make Q bigger than P here without loss of generality, because swapping their places won't affect this proof. So now I'll just scroll up the screen here to make some more room. And now I'll substitute in all the entries of matrix A for the entries of B, and we'll make this substitution in particular that contains the sum of rows P and Q. I've circled it in blue. We can then separate this sum into two sums because we're just expanding the brackets. I'll just scroll the screen up here again. We can take the constant C outside this sum like this. And we can set this sum to 0 because it represents the determinant of a matrix with two identical rows. We've proven this in a past video. And then we can eliminate this 0. I like to put this step in even though it's obvious, because I feel like not putting in this step would confuse the proof. So I'll just scroll the screen up yet again. We can write this sum in this shorter expanded form. And this so happens to be the determinant of matrix A. So we've proven this theorem, that the determinant of A is equal to the determinant of B. So I hope that you liked this video and that you found it to be helpful and educational. Please click like and subscribe if you did. Feel free to write anything helpful in the comments and to share this video, and thanks a lot for watching.